Welcome to Taxonomy Online Mathematics. In this video, we are continuing with the tutorial on the logarithm. We are done with the concept of logarithm, and in this tutorial, we are going to have the laws that govern the operations or the calculations in logarithm. So the first law is called the product rule. For the product rule, if I have a log of m times what? N with the base b. Let's say these two are in a bracket. Since it's a product, it becomes log b m plus log n what? To the base. That is simply means that if I have any log that is multiplying, as in, let's say if I have log 12 which to the base 3, which can also be seen, this is a product of 3 and 4. I can say that this is going to be log 4 times 3 to the same, let me use 5. So since I am multiplying, this is a product of two numbers. That is going to be log of 4 to the base 5 plus log of 3 to the base what? 5. That is what the product rule states. Then if I have the second one, which also says quotient, the quotient rule, which is also denoted by m over n to the base what? B. Since these two are dividing, we are going to have log of m base b minus log of n base b. So simply put, if you have any number, as in, let's say I have log, the base is 8 and I'm having, let's say 1.5. I am asked to express this. I know this is going to be log of 15 over 10 base 8. Since I am having the division as the quotient, that will produce log 15 to the base 8 minus log 10 to the base what? 8. That is per the quotient rule. We have the power rule. If I have log of m to the power k still with the base, what it means is that the exponent will now multiply the log to become k log m to the base b. Simply put, if I have log 5 exponent 3 to the base 10. Since this is an exponent, the exponent in 10 will multiply log 5 to the base what? 10. So that is for the power rule. So anytime you have a log that have an exponent, the exponent will multiply the whole log. The zero rule, which will be the log of 1 to the base b is equals what? 0. Meaning log 1 to the base b or to any base is equal to 0. So if you have, even if I have this to be log 1 base 10, you know the answer will be what? 0. Per changing from log to indices, we know this is going to be the base raised to the power 0. Any number raised to the power 0 will always give you what? 1. So a log of 1 will always produce what? 0. So anytime you have a log that is 1, log 1 is always 0. It doesn't matter what the base will be. Alright. we have what we call the identity rule, which is the log of b to the base b is going to be equals to what? 1. The difference between this and this. This one, they have the same number, that is log 5 base 5 is 1. The log, if the argument and the base are the same, this is the argument. If it's the same as the base, your answer is going to be 1, which we can still use the conversion from indices to log, as in, if I write this as log 15 base 15, if I say it is equals to 1, can it be true that 15 exponent 1 will it give me 15? Yes. 15 raised to the power 1 is the same as what? 15. So that is basically what that law is saying. The sixth one, we have log of what? Exponent. As in, we have log, let's say, we have b exponent k to the base b. We are saying the answer is k. This is the same as the power rule. The difference here is that this is having the argument here is the same as what? The base. If you look at this, it's the same thing. A number to exponent, a number to exponent. But in this case, we are having the base different from the argument. In this case, we are having what? The argument and the base being the same. And you are saying the answer is equals to the exponent. This is also true because if you have this, you have to use the power to multiply the log. Then this will in turn translate into the identity. Anytime you have argument and the base being the same, the answer is going to be 1. And that 1 will in turn multiply the k to give us k. I believe you get the idea. Meaning, if I want to assume that the base and the argument are different, it will be given to me as k log b base what? b. And the identity method or identity rule states that when the argument and the base are the same, then we are going to have what? 1. So k times 1 will give us what? K. That is what we have the log of exponent. Then we have exponent of log or of logarithm. If you have something like this, we have exponent of log. This is a number, the base are the same. Let's say I use different method. This our base. This is our how do you call it, log. Is becoming an exponent of a particular base. The answer we are looking for is just what? M. So these are the various rules upon which we are going to follow in order to solve questions or simplify any question given to us under logarithm. So under this, we will take some questions to summarize everything. For example, per all the laws that we have, we are to simplify 2 log 5 base a plus log 4 base a minus 2 log 10 base a. We are to simplify. Better still express them as a single logarithm. We say that anytime a log is multiplying, it becomes what? An exponent. So this will be log 5 square base a plus log 4 base a minus log 10 square base a. We are using the property 3 or the law 3. That is the power rule. Taking the power to become, the number to become a power. Then we are going to translate the addition to product rule. Meaning this is 25. So I'm having log 25 times 4 to the base A minus log 100 to the base A. I believe you know this. 25 times 4 will give you what? 100. So log 100 base A, log 100 base A. Also, subtraction will give us the quotient row. So we are going to divide. That will be log 100 over 100 base A. 100 over 100 will give us what? 1 base A. Which property give us this answer? If you have 1, as we can see here, then 0 power. Anytime there is a log, no matter what the base will be, the answer will be what? 0. So we can use the properties to solve questions under logarithm. Alright, thank you very much for watching. If you like this video, please give a thumbs up, leave a comment, share with your learning colleagues, and if you are new, don't forget to subscribe. See you in the next episode.